When we're looking at different redox reactions and we're trying to understand what molecule is getting reduced and what molecule is getting oxidized, the first thing to understand is what the electron carrier is actually doing. So I'm going to use this reaction step right here, which is from the middle of glycolysis, as an example. And let's talk about NAD plus, what it's doing, versus NADH. So NAD plus is kind of the empty form of the electron carrier. And then NAD plus, if it gains electrons, so I'm going to show electrons coming in here, if it gains electrons, then it becomes NADH. Okay, so that is something that's happening in this reaction over here that I've marked off. So if we look here, NAD plus is coming in, and that's what this arrow is showing when it's kind of feeding it in. NAD plus is coming in, and it leaves in the form of NADH. So what that means is that NADH is going to gain electrons in this, or another way to say it is that it is getting reduced. Of course, if it's gaining electrons, those electrons had to come from somewhere. So if we look at the other molecules involved in all of this, notice that what else is going into this reaction is right here, and that's the G3P, or glyceraldehyde 3-phosphate. So glyceraldehyde 3-phosphate is going to be losing electrons. It is losing the electrons to NAD+, because NAD+ is going to get them. And so when G3P loses the electrons, the end result of that is that it's going to be called by a different name. So that's this molecule down here, the 1-bisphosphoglycerate. And so that molecule is the end result. So if we wanted to label up here, G3P is going to lose electrons, or we could say that it is getting oxidized.